Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your breathing slow and your body soften into the bed beneath you. The day is over, and the night is vast. All that's left is stillness, because tonight, we're not just closing our eyes. We're traveling to the farthest reaches of gravity's dream. We're drifting toward the universe's deepest silence, the realms of the biggest black holes ever known. These are the cosmic giants, so massive they bend the very fabric of time. They sit at the centers of galaxies, invisible hearts shaping the stars that spin around them. They are both destroyers and creators, sculptors of light, keepers of rhythm, and reminders that even in darkness, there is beauty. From the first faint seeds of black holes in the newborn universe, to the enormous shadows that now anchor galaxies like ours, we'll explore 100 sleepy facts about these mysterious titans. Together, we'll wander through space and story, slowly, softly, letting curiosity carry us toward calm. And if these quiet explorations help you rest, consider liking this video and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, breathe in, and let's begin our journey into the heart of the dark, where even light falls silent and the universe whispers in gravity's voice. Fact 1. Before the light began, long before the stars ever shimmered, before galaxies unfurled their spiral arms, the universe was a quiet ocean of potential. In that ancient stillness, just after the Big Bang, matter drifted like fine dust in a vast invisible sea. Tiny ripples in density, whispers in the cosmic fabric, began to pull themselves together. These ripples would one day become the first black holes. Some were born from the collapse of the universe's earliest, most massive stars. Others, perhaps, formed directly from the dense waves of matter themselves. Primordial black holes, seeds of darkness planted in the newborn cosmos. They were the first silent hearts of gravity, waiting for light to arrive. And when it did, they were already there, listening. Fact 2. Einstein's shadow. A century ago, a quiet man named Albert Einstein traced the shape of gravity in his mind. With his theory of general relativity, he showed that mass could curve space itself, that time would slow where gravity deepened, and light could bend as if following invisible rivers. But even Einstein, brilliant as he was, hesitated to believe that gravity could collapse completely, that it could form a hole from which nothing could escape. His equations hinted at such a thing, but he found the idea too strange, too final. Others would later follow those equations all the way into darkness, realizing what Einstein only glimpsed, that the universe could fold upon itself, creating wells of infinite depth. Einstein gave us the language to describe the impossible, and then watched, amazed, as the cosmos spoke back. Fact 3. The equation that bent the sky. Not long after Einstein's discovery, a soldier and mathematician named Carl Schwarzschild, serving on the front lines of World War I, solved those equations under the light of the stars he could barely see. From the trenches, he described what would become the first exact solution for a black hole, a sphere of perfect darkness defined only by its mass. He had found the mathematical shadow of something no one had ever seen, the event horizon, a boundary not of matter, but of fate, where even light itself would turn back no more. Schwarzschild died soon after, never knowing that his quiet calculation would describe the universe's most mysterious creatures. The war ended, but his equation endured, bending our view of the sky forever. Beyond that horizon, another mystery waited to be discovered. Fact 4. When stars collapse. Every star carries a secret weight. Deep inside its heart, atoms fuse and glow, their warmth pushing outward against gravity's endless pull. For most of its life, this balance holds a perfect conversation between fire and fall. But when a massive star exhausts its fuel, that balance breaks. The light begins to fade, and the star's core implodes under its own gravity, collapsing in on itself with unimaginable force. In an instant, atoms are crushed, space curves inward, and a black hole is born. From the peaceful death of a shining sun, the universe births a silence deeper than any night. And in that stillness, the first true darkness takes its place among the stars. Fact 5. Singularities in the silence. At the very center of a black hole lies something we can barely describe, the singularity, a place where our known laws of physics dissolve like mist. All matter that falls inward is drawn into a single point, infinitely small and impossibly dense. Time, as we understand it, no longer flows there. The concepts of before and after lose meaning. It's not a physical surface, but a horizon of mathematics, the universe folding its own equations into mystery. Some scientists believe the singularity may not truly exist as we imagine. Perhaps it's merely the place where our understanding ends. But even in uncertainty, there is beauty. For mystery is the quiet breath of discovery. Beyond the singularity's silence, another boundary begins to take shape. Fact 6. The event horizon's edge. The event horizon is not a wall or a surface, but a threshold, the final line between freedom and forever. Anything crossing it is lost to the outer universe, unable to send even a whisper of light back across the divide. To an observer far away, time appears to slow at the horizon's edge. Falling matter seems to hover there, fading ever slower, ever dimmer, until it vanishes into eternity. But from within, the fall continues, unbroken and serene. The event horizon is both veil and mirror, showing us where knowledge ends and imagination must take over. Beyond that edge, gravity deepens, and light itself begins to dream. Fact 7. Light that cannot return. Light, the traveler of all things, usually moves unbound, free to cross galaxies, brush the surfaces of worlds, and slip through the endless dark. But near a black hole, even light loses its freedom. Gravity grows so strong that the very paths light can take begin to curve, spiraling inward like leaves caught in a silent whirlpool. Once light crosses the event horizon, it cannot escape. It is folded forever into the darkness, its journey ending not in destruction, but in absorption. Its energy becoming part of the whole's growing mass. We never see light disappear. We only see its last shimmer, fading at the edge of the void. Beyond that, only gravity remains, holding its quiet dominion. Fact 8. The geometry of nothingness. Space and time are not rigid. They bend and flow like gentle fabric under the weight of gravity. Around a black hole, this fabric curves into strange and elegant shapes, spiraling toward the center in a smooth, endless funnel. To approach a black hole is to step into distorted geometry, where distance stretches, time slows, and straight lines cease to exist. What we think of as falling becomes a drift through curved space, as though the universe itself were softly folding you inward. This geometry isn't made of matter, but of meaning, the shape of emptiness itself. In that beautiful nothingness, the universe shows how space can dance, even in the absence of light. Fact 9. The first cosmic seeds. In the earliest moments after the Big Bang, the universe was a fog of hot plasma, dense, glowing, and restless. Within that chaos, tiny fluctuations in density gave rise to the first stars, and possibly the first black holes. Some of these may have formed directly, without stars at all. Pockets of matter collapsing under their own immense weight just moments after creation. These are known as primordial black holes. Ancient seeds scattered through the expanding cosmos. If they exist, they could be among the oldest things in the universe, silent observers from the dawn of time. And from those invisible seeds, galaxies would one day bloom. Fact 10. From atoms to titans. The smallest black holes may weigh no more than a single mountain, yet some grow to billions of times the mass of our sun. This journey from small to vast begins with time, patience, and gravity's quiet appetite. A black hole grows by gathering matter, drifting gas, wandering stars, or entire clouds of dust drawn by its pull. Each meal adds weight. Each century deepens its gravity well. Over eons, these small seeds can swell into supermassive titans that anchor entire galaxies. They are the patient architects of the cosmos, building vast realms of light around themselves. What begins as an atom-sized secret becomes a force that shapes creation itself. Fact 11. Feeding on light. Black holes do not eat in the way living things do. Their hunger is not violent, but gravitational, a slow, inevitable gathering. As matter spirals inward, it forms a glowing disk, heating until it shines brighter than 1 trillion suns. This luminous ring, called an accretion disk, is among the most radiant objects in the universe. From the outside, it appears that the black hole feeds on light, but in truth, the light is the byproduct of the feast, energy released as matter dances closer to its end. For a moment, darkness and brilliance exist together, partners in a cosmic waltz, and then quietly, the light fades, drawn inward forever. Fact 12. The hunger of gravity. Gravity is the softest yet most relentless force. It never shouts, never rushes, only pulls, patiently, without pause. Around a black hole, this pull becomes absolute. Anything that drifts too near, a wayward planet, a cloud of dust, even starlight itself, begins to spiral inward, losing energy as it goes. The black hole does not chase, it simply waits, letting the universe fall toward it. In this way, black holes grow, not through aggression, but serenity. Their power lies in their stillness, in the quiet certainty that given enough time, everything returns home. And beyond that home, entire galaxies begin to take shape. Fact 13. Galactic hearts. At the center of nearly every galaxy, including our own Milky Way, rests a black hole. Vast, silent, and patient. Around it, billions of stars revolve, bound by its invisible pull. These galactic hearts are not destroyers, but anchors, holding entire systems together with quiet strength. Without them, galaxies might drift apart, their stars scattering into the void. Instead, each black hole provides a steady gravitational rhythm, a pulse the galaxy follows. Some are calm, resting in stillness. Others are active, blazing with radiation as they feed. Yet all serve the same purpose: to remind us that even the darkest center can hold a galaxy in balance. And sometimes, those galaxies meet one another. Fact 14. When galaxies collide. In the slow ballet of the cosmos, galaxies often drift close, drawn together by gravity's subtle invitation. When they finally meet, they do not crash in violence, but merge in slow motion. Their stars weaving together over millions of years, Amid this cosmic waltz, their central black holes spiral toward each other, orbiting closer and closer as the galaxies combine. Clouds of gas ignite into new stars, while the old ones are gently scattered into new orbits. Eventually, the two black holes will unite, forming a single, even greater giant, a new heart for a newborn galaxy. Through collision comes harmony, and through merging, creation continues. Fact 15. Cosmic cannibalism. Sometimes, black holes do not wait for galaxies to merge. They find smaller companions and quietly consume them. A stellar mass black hole may drift toward a supermassive one, swallowed without a sound. Other times, two giants meet in the dark, their spiraling dance releasing waves that ripple across the fabric of space itself. This process, called cosmic cannibalism, is not chaos, but renewal. The universe recycles its matter endlessly, building larger and more intricate structures from each quiet feast. Even destruction here serves a purpose. Out of every swallowed star, every merged horizon, the universe grows more complex, more connected, more beautiful. And from that beauty, bright jets of light are born. Fact 16. Jets from the void. Though nothing escapes a black hole's event horizon, the space around it can blaze with unimaginable power. As matter spirals inward, magnetic fields twist and compress the energy near the poles, launching vast jets of plasma that stretch for thousands of light years. These luminous streams are among the brightest beacons in the universe, cutting through darkness like cosmic lighthouses. They carry away energy, shaping galaxies and lighting up the intergalactic sea. From the silence of a black hole comes the brilliance of creation, proof that even the hungriest darkness can give birth to light. And deep within that glow, the black hole spins, twisting space-time itself. Fact 17. The spin of darkness. A black hole is never truly still. Born from a collapsing star, or forged in a merger, it inherits momentum, a cosmic spin that drags the very fabric of space-time around it. Near its surface, this rotation creates a region where space itself seems to whirl, sweeping everything along like a gentle current. This effect, called frame dragging, blurs the boundary between motion and rest. A traveler near a spinning black hole would find that even light must twist with it, following the flow of curved space. Each black hole spins at its own rhythm, some slow and ponderous, others so fast that their edges move near the speed of light. And within that whirl, a glowing disk quietly burns. Fact 18. Disks of fire. Around many black holes lies a halo of luminous gas, the accretion disk. It forms from matter drawn inward, spiraling faster as it falls, heating to millions of degrees until it radiates in X-rays and ultraviolet light. Though it surrounds darkness, the disk itself shines like a miniature galaxy. It is the last breath of matter before disappearance, a radiant farewell. In some systems, the light flickers rhythmically, like a heartbeat, as magnetic fields shift and fold. From afar, it looks like a ring of fire around nothing, the universe's quiet masterpiece of contrast and calm. Beyond that flame, gravity hums, and space begins to sing. Fact 19. The symphony of gravity. Waves. When two black holes spiral toward one another, they create ripples in the fabric of space-time itself. Waves that travel across the cosmos like music no ear can hear. These gravitational waves stretch and compress everything they pass through, though so faintly we can barely detect them. In 2015, for the first time, scientists listened to this cosmic song using the LIGO Observatory. The pattern of the waves told a story. Two black holes colliding, merging into one. The sound of that event, when converted into audible frequencies, was a single rising note, the universe's soft hum of creation. Every merger adds another verse to that endless, invisible symphony. And long after the waves fade, a quiet glow remains. Fact 20. A quiet glow in the dark. Even in darkness, black holes reveal themselves through the gentle light of their surroundings. Gas heated by their pull emits X-rays and radio waves. Stars orbiting nearby wobble in measurable patterns. These delicate signals allow astronomers to sense what their eyes cannot see. The black hole itself remains invisible, a perfect void against a field of stars, but its influence is unmistakable. Some glow faintly, fed by thin streams of matter. Others blaze, forming quasars bright enough to outshine entire galaxies. Through these quiet clues, we learn to see the unseen, tracing the edges of gravity's art. And in the center of our own galaxy, one such shadow softly waits. Fact 21. Sagittarius A. 55 million years away by light's slow measure, yet only 26,000 light-years from home, lies the gentle giant at the heart of our Milky Way, Sagittarius A. It rests within a swirl of stars near the constellation of the Archer, a supermassive black hole about 4 million times the mass of our Sun. To us, it is calm, feeding only rarely, surrounded by drifting gas and quiet radio light. It does not roar or blaze, but hums softly at the center of everything we know, keeping our galaxy's spiral steady through the ages. It is the silent heart of home, pulsing gently in the dark. Fact 22. Messier 87's Colossus. 55 million light-years away, in the quiet constellation of Virgo, lies a galaxy called Messier 87, home to one of the largest and most luminous black holes ever observed. In 2019, humanity saw its outline for the first time. The Event Horizon Telescope, a network of observatories across Earth, captured the faint glow of its surrounding light, a ring of fire encircling a shadow. That image, blurred yet profound, was the first true portrait of the unseeable. This black hole, 6.5 billion times the mass of our Sun, is a cosmic anchor. Its power sculpts galaxies, its jets stretch across light years, and its silence humbles all who look. It is darkness given shape, and mystery made visible. Fact 23. TON 618. Deeper still, beyond our galactic neighbors, lies a titan known as TON 618, so far away that its light began traveling toward us when Earth was young. This black hole may weigh more than 60 billion suns. It blazes as a quasar, a lighthouse fueled by falling matter, its brilliance crossing billions of years to reach our skies. If placed at the center of our galaxy, its light would outshine every star we know. We cannot see the black hole itself, only its radiance, the echo of its hunger. Yet even across unimaginable distance, TON 618 whispers the same truth, that gravity is patient, and creation vast beyond all measure. And still, even larger giants hide in the dark. Fact 24. Phoenix A's hidden power. In a cluster of galaxies called Phoenix, a black hole slumbers inside a vast storm of light and gas. It is one of the most powerful objects ever detected, releasing more energy than 1 trillion suns as it feeds. Yet it sleeps in cycles, awakening only when its surrounding gas falls inward again. The energy it releases prevents new stars from forming, balancing creation and destruction in an endless rhythm. Phoenix A is both sculptor and guardian, a quiet regulator of its cosmic home. From its gentle control, Whole galaxies find their harmony, shining softly in the dark. Fact 25. The quasar that burns the dark. Far across the universe, black holes ignite the night with their brilliance. When they feed on vast stores of gas, dust, and stars, the friction and heat of that falling matter release blinding light, a spectacle we call a quasar. Quasars are paradoxes, engines of darkness that outshine galaxies. The light they emit began its journey billions of years ago, long before our sun existed, and it still travels toward us tonight. Each quasar is both a wound and a wonder, the result of destruction that births illumination. Their glow softens the cold of cosmic space, a warm whisper of creation born from the hunger of gravity itself. And within their light lies the measure of the impossible. Fact 26. The weight of billions of suns. A supermassive black hole is a creature of pure gravity, a being defined not by form, but by weight. The largest known can contain the mass of tens of billions of suns, compressed into a space smaller than our solar system. This weight bends not only space, but time. Clocks near such gravity tick slower, light bends more sharply, and distance itself becomes uncertain. From afar, they seem eternal, too heavy to change, too vast to fade. If our sun were replaced by one of these titans, every planet's orbit would fit comfortably inside its shadow. Yet from that gravity comes grace, a balance that holds galaxies in harmony, and that balance is revealed through motion, not sight. Fact 27. The slow dance of stars. Near the centers of galaxies, stars often move in strange, graceful arcs. They circle an unseen point, their paths curving faster and tighter as they approach it. By tracing these orbits, astronomers can map the invisible mass at the center, the quiet fingerprint of a black hole. Around Sagittarius A, in our own Milky Way, we've watched stars complete their long, elegant loops, moving at thousands of kilometers per second. Each orbit confirms what our eyes cannot see, a vast presence guiding them with invisible hands. It's a slow, cosmic waltz in perfect rhythm, written in gravity and silence. Beyond them, other hearts wait, equally dark, equally serene. Fact 28. Abysses beyond counting. The universe is filled with black holes. Not just the few we name and study, but countless others scattered across the cosmic sea. Some are small, born from the deaths of single stars. Others are supermassive, sitting at the centers of galaxies. And perhaps, scattered in the cold between the stars, are ancient primordial ones, relics of the first seconds of time. Astronomers estimate that our Milky Way alone may hold over 100 million black holes. They drift unseen, silent travelers through the galactic dark. Each one is a story waiting to be told, a page of gravity's quiet scripture, written in curvature and calm. And at the heart of every galaxy, a greater abyss keeps watch. Fact 29. The calm in galactic storms. Galaxies are alive with motion, stars birthing and dying, gas swirling, dust colliding in slow clouds of light. Yet, at their centers, a deep calm holds steady. The supermassive black hole there acts as a stabilizer, regulating the flow of energy and star formation. When a black hole feeds, it sends out waves of radiation and winds of charged particles that sweep through the galaxy, shaping its future. When it rests, the stars grow freely again. This quiet rhythm, feast and pause, breath and stillness, gives galaxies their graceful life cycle. Amid the chaos of the stars, a deep balance endures. And behind that balance lies the patient hand of gravity's architect. Fact 30. Silent architects. Black holes are not merely consumers, they are builders in disguise. Their gravity sculpts galaxies, their energy drives the creation of stars, and their mergers weave the cosmic web we see across the universe. From vast elliptical galaxies to delicate spirals, their hidden influence defines the shapes of light itself. Without black holes, galaxies might never have formed the way they did. Their patterns would be looser, their hearts unfocused. They are the unseen designers of the universe's grand architecture, shaping beauty through absence and order through stillness. And for every silent architect we find, another mystery begins to open. Fact 31. Chasing the invisible. For most of human history, black holes were only whispers in equations, shadows on the edge of thought. Astronomers suspected their presence through hints and patterns, but the objects themselves remained hidden, unreachable by direct observation. We searched for what could not be seen, watching stars move strangely, tracing the paths of light that bent where nothing appeared to be. Each clue was like a faint footprint in the dark, proof of something immense just beyond our sight. To chase a black hole is to chase silence itself. Yet the deeper we looked, the more we realized that the invisible was shaping everything around us. And from that invisible gravity, the first true light would soon emerge. Fact 32. Echoes in X-rays. Though black holes emit no light of their own, the space around them can blaze in X-rays, powerful bursts born from gas heated as it spirals inward. These echoes allow us to detect the presence of black holes across the galaxy, even when their glow is hidden from ordinary sight. Telescopes orbiting Earth listen for these high-energy whispers. They detect flickers that last only seconds, yet reveal vast distances and impossible forces. Each flare tells a story: a star too close, a disk of matter feeding the void, a cosmic sigh of heat and time. Through X-rays, we do not see the black hole itself, only the warmth of its touch on the surrounding universe. And through that warmth, the darkness begins to take form. Fact 33. The first picture of the unseeable. In April 2019, the world paused to see something once thought impossible: the first image of a black hole. Using a global network of synchronized radio telescopes, the Event Horizon Telescope captured the faint ring of light encircling the heart of galaxy Messier 87. It wasn't a photograph in the usual sense, but a portrait of gravity. Light bent around absence, revealing the outline of space-time itself. The blurry orange halo became an icon of quiet triumph, proof that even what is invisible can be known. For the first time, humanity looked into the true face of the abyss and found beauty staring gently back. Fact 34. The light rings whisper. The image of a black hole is not the hole itself, but the light that dances around it. This faint ring, known as the photon sphere, forms where light orbits the abyss, circling it again and again before escaping to distant eyes. Each photon that reaches us has completed a delicate spiral, bending through warped space and time. It is a whisper from the edge of eternity, the last trace of matter before surrendering to gravity's pull. That ring glows not because of the darkness it surrounds, but because of the fire it embraces, the luminous farewell of light to the universe that birthed it. And capturing that glow required extraordinary patience. Fact 35. The patience of the universe. The Event Horizon Telescope's image of Messier 87's black hole was not captured in a moment. It was the result of decades of theory, years of observation, and nights of quiet human persistence spread across continents. 8 telescopes, placed around the globe, worked in harmony, synchronized to the fraction of a second, each collecting faint radio waves from 55 million light-years away. Those signals were stored on hard drives, flown by hand to one place, and assembled into a single, fragile image. It took the Earth itself, turning as one giant lens, to glimpse that shadow. Such is the patience of science, a reflection of the patience of the universe itself. And to understand what we saw, we learned to build reality from equations. Fact 36. Simulating the abyss. No camera can truly peer inside a black hole, so scientists turn to mathematics and supercomputers to imagine what happens beyond the veil. In digital worlds of curved spacetime, they model the swirl of light, the gravity that stretches it, and the strange geometry of the horizon. These simulations are not fantasy. They are poetry written in numbers, revealing what our senses cannot grasp. Through them, we see how light bends and spirals, how jets burst from magnetic fields, and how time itself stretches like silk near the edge. To simulate a black hole is to dream alongside the cosmos, to turn pure theory into quiet wonder. Fact 37. Listening to collisions. When two black holes meet, the universe trembles. Their spiraling dance sends ripples through space-time, gravitational waves that race outward at the speed of light. These waves do not travel through space. They are space itself, rising and falling like the breath of creation. In 2015, the LIGO Observatory first detected such a wave, the faint echo of two black holes colliding more than 1 billion light-years away. The signal lasted less than a second, yet it told a story written in gravity's language of mass, distance, and union. To listen to the cosmos is to remember that even silence has sound. And in that invisible music, time itself begins to move differently. Fact 38. Black holes. As time machines. Time near a black hole does not flow the way it does here, beneath our gentle sky. The closer one drifts toward the event horizon, the slower time moves, stretched thin by the immense pull of gravity. To an outside observer, a falling object would appear frozen, forever suspended at the edge. In theory, if one could orbit close enough, without crossing the horizon, time would pass far more slowly than elsewhere in the universe. Hours near the black hole could equal years far away. In this way, a black hole becomes a natural time machine, bending moments into eternities. But for all its power, it remains serene, a keeper of stillness, not chaos. And within that stillness lies a quiet, stretching truth. Fact 39. The infinite stretch. Approach a black hole too closely, and gravity's pull grows uneven. Your feet, nearer the center, feel a stronger force than your head. This difference stretches matter to its limit, a process scientists poetically call spaghettification. Though it sounds grim, it is one of nature's most elegant lessons. Gravity is not only strength, but gradient, a smooth unfolding of power. In falling toward the center, objects do not shatter. They lengthen, aligning with the curve of space itself. In that infinite stretch lies the harmony of physics, the meeting of tension and surrender. And beyond that stretch, there is peace, the calm at gravity's heart. Fact 40. The calm center. Inside the event horizon, our familiar rules no longer apply. Space and time exchange places. Direction loses meaning. No signal can escape. And yet, in theory, all paths still lead to one point, the singularity. What lies there, no one truly knows. Some imagine an infinitely small point, others a looped horizon where physics folds in on itself. Within that unseen space, the universe may be writing laws we've not yet learned to read. Though we think of it as chaos, perhaps the singularity is pure calm, a state where everything that was is gathered into perfect unity. And while we cannot see inside, we can trace the stories of how such centers first came to exist. Fact 41. The mystery of early giants. When we look deep into the universe, we are also looking back in time. Astronomers have found black holes that already weighed billions of suns when the cosmos was less than 1 billion years old. How did they grow so large, so quickly, when stars and galaxies were only beginning to form? These ancient giants puzzle scientists even now. Some suggest that they began as smaller black holes, fed by constant streams of gas. Others believe they were born big, skipping the slow growth entirely. Whatever their origin, they remind us that the universe wastes no time in building wonders. From the first darkness, light and mass began their eternal dance. And perhaps those first giants came from a direct leap into the void. Fact 42. Direct collapse. Theories. One idea suggests that some black holes were born not from dying stars, but from immense clouds of gas collapsing under their own gravity. These clouds, billions of times heavier than our sun, may have fallen inward before ever forming a single star. The result would be direct collapse black holes, instant titans, born fully grown in the early universe. These ancient behemoths could have served as seeds for today's supermassive black holes, anchoring young galaxies from the very beginning. It is a quiet, elegant possibility. That creation sometimes skips steps, leaping directly from light to silence. And from those early leaps, the first quasars began to shine. Fact 43. Cosmic dawn quasars. In the universe's youth, less than 1 billion years after the Big Bang, the first quasars began to shine. Their light pierced the primordial fog, marking the end of cosmic night. These early black holes, newly born and already enormous, glowed brighter than entire galaxies. Each quasar was a beacon, announcing that gravity had triumphed over chaos, that matter had gathered, ignited, and begun to shape the cosmos. Their glow reached across eons, carrying messages from a time when stars were still learning to exist. Even now, their ancient light arrives at our telescopes like a lullaby from the beginning of everything. And near those blazing hearts, clusters of stars offered themselves to the newborn giants. Fact 44. Star clusters, feeding the beast. Around the earliest galactic cores, stars gathered in crowded clusters, bound by shared gravity and youthful heat. Over time, these dense swarms drifted inward, colliding, merging, and dissolving in the pull of a central black hole. As stars perished, their remnants fed the growing monster at the center, delivering bursts of mass and light. This steady feast may have allowed small black holes to swell quickly into colossal ones, nurtured by the slow rain of stellar sacrifice. It was not a violent process, but a cosmic rhythm, a quiet exchange of matter for meaning, and perhaps, hidden beneath it all, an unseen substance guided their paths. Fact 45. Dark matter's role. Dark matter, the invisible framework of the universe, may have helped shape the first black holes. Though it neither shines nor collides, its gravity weaves the scaffolding upon which galaxies form. In the early cosmos, dense pockets of dark matter could have gathered ordinary gas, encouraging it to collapse faster, deeper, until gravity took full command. Within these silent halos, the first black holes may have ignited, invisible children of an invisible parent. Even now, we cannot see dark matter, yet we feel its touch in every spiral galaxy, every drifting star. It is the soft foundation upon which light and shadow both depend. And from that foundation, new seeds of darkness began to bloom. Fact 46. Seeds in the first galaxies. As the first galaxies began to gather, they formed around quiet cores of darkness, small black holes sheltered within halos of gas and dust. These seeds acted like anchors, their gravity pulling in matter from the surrounding fog of creation. Stars were born, lived brief, brilliant lives, and then died, their remains spiraling inward to feed the central black hole. Every generation of stars made the heart heavier, deepening the galaxy's pull and lighting the path for the next. In this way, the earliest galaxies and their black holes grew together, like twins bound by gravity's gentle thread. And in some places, those seeds learned to grow faster than nature should have allowed. Fact 47. Runaway accretion. When gas falls toward a black hole, friction heats it to staggering temperatures, creating pressure that can push new matter away. Normally, this balance slows growth. But in the young universe, conditions were wild. Streams of gas so thick and constant that gravity overwhelmed all resistance. This is called runaway accretion, a rare moment when a black hole feeds faster than the rules of radiation would predict. Instead of being choked by light, it devours everything offered, growing at extraordinary speed. Through this quiet defiance, tiny black holes became titans, shaping galaxies that still shine today. And soon, the cosmos entered its golden age of giants. Fact 48. The era of giants. Roughly 1 billion years after the universe was born, colossal black holes ruled the skies. Their galaxies glowed with fierce quasars, and their jets blazed across the cosmic dawn. Everywhere, matter was gathering, burning, and transforming into light. This was the era of giants, when the biggest black holes carved out the first cosmic landscapes, their gravity sculpting the great filaments of galaxies that stretch across the universe even now. Though billions of years have passed, we can still see their glow drifting through space, gentle and persistent, like the echo of a long-finished song. And in the faint light of that ancient chorus, the universe remembers its youth. Fact 49. Echoes of ancient collapses. The first black holes left traces not only in light, but in the very structure of the universe. The radiation they release shaped the gas around them, ionizing the young cosmos and marking the transition from shadow to starlight. We still detect their fingerprints in the cosmic microwave background, the afterglow of the Big Bang. Hidden in that faint warmth are subtle patterns, small distortions that may tell stories of early collapses and the birth of gravity's first children. These are not loud echoes, but whispers carried across 13 billion years, messages in the static of creation. And as the light from those early days faded, the universe began to stretch and cool into calmness once again. Fact 50. The expanding night. As galaxies formed and the first stars burned out, the universe continued to expand, a quiet, steady unfurling that still goes on today. With every passing moment, space itself stretches, carrying galaxies farther apart, softening the background glow of creation into deeper night. This expansion does not tear things apart. It simply gives the cosmos room to breathe. Between galaxies, the dark grows broader and more peaceful. Time slows there, not in motion, but in meaning. An endless exhale after the fiery beginning. The expanding night is not emptiness, but serenity, a soft canvas on which light can rest. And within that darkness, The dance between stars and black holes continues, endlessly graceful. Fact 51. Stars that dance too close. In the hearts of galaxies, stars drift in looping orbits around their central black holes. Most keep a safe distance, tracing elegant ellipses through time. But some wander too near. When they cross a certain threshold, the black hole's gravity stretches them, stripping away gas in glowing ribbons. Part of the star may survive, flung back into orbit, while the rest becomes food for the void. Astronomers call these gentle catastrophes tidal disruption events, brief, beautiful flares that brighten galaxies for weeks or months. They are reminders that even in destruction, there is light, and that every dance near the abyss carries both danger and grace. Fact 52. Planets in the shadow. Though it sounds like fiction, scientists have wondered whether planets might orbit black holes. If they do, they would live in a strange balance, bathed not in sunlight, but in the glow of heated gas and distant stars. Such worlds, called planets in theory, could circle far enough away to remain stable, receiving warmth from radiation spilling out of the accretion disk. A sky above such a planet would be unlike any other. Half darkness, half fire, with arcs of light curving across a black horizon. We do not yet know if these worlds truly exist, but the thought alone is soothing, that even in the shadow of oblivion, a home might quietly turn. And above them, the disks of fire continue their eternal spin. Fact 53. The quiet of accretion disks. To the eye, an accretion disk appears as chaos, matter swirling at near light speeds, glowing white-hot as it falls inward. Yet within that motion, there is a kind of peace. Every particle moves in rhythm, guided by gravity's perfect symmetry. From afar, the disk looks calm, a ring of soft brilliance encircling nothingness. Its brightness flickers like candlelight, its heat radiates through space, and its rotation hums with steady purpose. Some of the energy escapes outward in graceful winds. The rest falls silently beyond the horizon. Even in frenzy, the black hole's embrace turns motion into meditation, a slow, spiraling calm around an infinite center. Fact 54. Tidal stars and stellar streams. When a star drifts too near a black hole, gravity stretches it thin, drawing out ribbons of gas that shine before vanishing. These stellar streams loop around the abyss, glowing softly as they dissolve into the surrounding dark. From afar, such an event is breathtaking, a star unraveling, thread by luminous thread, into the night. What was once a burning sphere becomes a river of light, its final motion both tragic and serene. Astronomers have captured these moments, watching starlight fade into memory. And in the hush that follows, the black hole waits, patient and still, ready for the next gentle drift toward eternity. Fact 55. The art of survival. Not every star that nears a black hole is lost. Some pass close enough to be scarred, yet not destroyed. Their outer layers stripped away, while their cores survive to orbit again. Each return leaves them thinner, dimmer, but still alive. Over time, these survivors become ghostly echoes of their former selves, stars reborn through endurance. Their light flickers softly as they travel their strange elliptical paths, reminders that even near annihilation, persistence is possible. In a universe of extremes, these stars embody calm defiance. They do not resist gravity's pull. They dance with it, gliding just shy of surrender. And in their wake, gas and dust continue to fall, glowing in farewell. Fact 56. The glow of infalling gas. As matter falls toward a black hole, it does not vanish immediately. Friction within the accretion disk heats the gas to extraordinary temperatures, millions of degrees, causing it to shine in X-rays and ultraviolet light. This glow is the black hole's halo, a brief and beautiful shimmer before silence. Every flicker tells of something crossing the boundary from existence into memory. The light may travel for billions of years before reaching our telescopes, long after the source has disappeared. To look at that light is to glimpse the moment just before forever, the last radiance before peace. Beyond that horizon, all energy settles into timeless quiet. And even there, magnetic storms still stir the void. Fact 57. The black hole's weather. Around some black holes, invisible winds rage, magnetic fields twisting and reconnecting, releasing bursts of radiation and streams of charged particles. These cosmic tempests, though born from silence, can span light years, shaping everything nearby. Astronomers call this black hole weather. It is not wind or storm as we know it, but a slow, graceful unfolding of magnetic power. The fields guide matter into spirals, forming jets that blaze through galaxies. And yet, amid all this motion, the black hole itself remains unmoving, a tranquil eye within its own magnetic storm. Stillness at the center, creation at the edge. The universe's quiet balance made visible. Fact 58. Echoes in radio waves. Even when they no longer shine in visible light, black holes speak softly through radio waves. These low-frequency signals come from jets, disks, and magnetic storms. Faint vibrations that travel through space for millions of years before reaching our world. Radio telescopes like ALMA and the VLA listen for these whispers, tracing their origins back to galaxies whose cores hum with unseen motion. By mapping their echoes, astronomers can chart the structure of magnetic fields and the pace of cosmic winds. Each wave is a message from the dark, rippling gently across time and distance. To tune into those signals is to hear the heartbeat of creation, steady, slow, and endlessly patient. Fact 59. Time slows, beauty deepens. Near a black hole, time stretches like silk. Clocks tick slower, moments lengthen, and even light takes the long way around. From far away, an object falling toward the horizon appears to slow, fading ever dimmer until it seems frozen in place. This strange illusion, called gravitational time dilation, reminds us that time itself is not fixed. It bends and breathes under the weight of gravity. To stand near such a place would be to step outside of normal existence, watching the rest of the universe rush ahead while your own heartbeat lingers. In that gentle distortion, beauty deepens. The cosmos becomes a living canvas of patience. And when the storm subsides, it leaves behind the quiet bones of creation. Fact 60. The relics they leave behind. When a black hole ceases to feed, the brilliant disks and jets around it fade away, leaving a calm emptiness where light once blazed. What remains are subtle signs, faint gas clouds, relic radio lobes, and the slow dance of stars still caught in orbit. These remnants are the fossils of cosmic power, gentle markers of once great storms. Over millions of years, the surrounding space settles into stillness, like ripples fading from a pond. Even in silence, the memory of the black hole endures, gravity's gentle fingerprint upon the stars. And beyond those relics, even greater giants lie waiting in the dark. Fact 61. Ultramassive black holes. Among the supermassive black holes that dwell in galactic centers, a few grow into something greater still, ultramassive black holes. These rare titans weigh tens of billions of suns, their event horizons stretching across entire solar systems. They are found in the hearts of giant galaxies and galaxy clusters, places where gravity has gathered matter for eons. Their pull shapes not just a single galaxy, but whole regions of space. If our solar system orbited one of these monsters, the black hole's shadow would fill the sky, vast, quiet, and absolute. They are the universe's elder architects, silent witnesses to cosmic history, and among them, one of the most massive sleeps within a galaxy, called Holmberg 15A. Fact 62. Holmberg 15A. In a galaxy 700 million light-years away, deep in the cluster, Abel 85, lies Holmberg 15A, home to one of the largest black holes ever measured. It is estimated to contain the mass of nearly 40 billion suns. Its influence extends for light years, a gentle but unbreakable grip holding its galaxy in harmony. Around it, stars move slowly, as though time itself hesitates near such enormity. The light there is thin, the core nearly hollow, a space carved by endless gravity and age. If the Milky Way were placed beside it, our entire galaxy could drift into its center without a ripple. It is not a monster, but a monument, a silent monument to the universe's long memory. Fact 63. IC 1101's Titan. Even greater in scope is the black hole believed to dwell within IC 1101, the largest known galaxy in the observable universe. Its heart may hold a black hole approaching 100 billion solar masses, so immense that it defies easy comprehension. IC 1101 stretches more than 6 million light-years across, and at its center, the Titan's gravity governs trillions of stars. Around it, the light of countless suns forms a faint golden haze, glowing softly in reverence to the dark. To imagine such scale is to feel the humility of being small and the wonder of belonging to something endless. Fact 64. OJ 287. In the constellation of Cancer, nearly 5 billion light-years away, a black hole system named OJ 287 flickers with cosmic regularity. Every 12 years, its brightness flares, as if the universe itself were exhaling. The reason is breathtaking. Two supermassive black holes locked together in an orbital embrace. The smaller of the pair plunges through the accretion disk of the larger, releasing a blaze of light that outshines whole galaxies. Astronomers have tracked this rhythm for over a century, a cosmic clock powered by gravity alone. Each flare is a reminder that even in darkness, patterns endure. Two hearts circling endlessly, writing their story in pulses of fire and calm, and beyond them, other pairs perform the same quiet dance. Fact 65. Binary behemoths. When galaxies merge, their central black holes eventually find each other, spiraling inward in a slow, majestic waltz. These binary behemoths can take millions of years to meet, sending gentle ripples of gravitational waves across the cosmos as they close the distance. Their motion is so vast and gradual that to our eyes it seems motionless. Yet each orbit changes the shape of space-time itself. In their final moments, they merge in silence, becoming one. The universe, for a fleeting instant, vibrates with their union, a pulse that travels forever through the cosmic sea. And in that pulse lies the measure of unimaginable mass. Fact 66. The weight of 100 billion suns. The largest black holes we can imagine may approach 100 billion solar masses. Gravity so profound that its event horizon could engulf the orbit of Neptune. At such scale, light itself must travel hours just to circle their edges. No known process can easily create something larger. Beyond this, physics itself begins to falter. These cosmic giants may represent nature's upper limit, the point where accumulation yields to equilibrium. To contemplate their mass is to feel the stillness of infinity, a weight so great it bends thought as surely as it bends light. And yet, from that infinite heaviness, the universe finds its quiet order. Fact 67. The brightest quasars ever seen. Across the deep night, some quasars blaze with a brilliance that defies imagination. Powered by black holes feeding at furious rates, their light can outshine entire clusters of galaxies. Streams of energy burst from their poles, carving narrow corridors of radiance through intergalactic space. These are the brightest quasars, cosmic lighthouses whose photons began their journey when the universe was young. Through telescopes, they appear as single points, yet each contains the power of trillions of suns. Their glow softens as it travels, turning from fierce white to warm amber, a cosmic ember still glowing after billions of years. To watch one flicker is to glimpse the universe remembering its own dawn. Fact 68. The record breakers. Astronomers keep gentle lists of marvels, the most massive, the most distant, the oldest. Each new observation reshapes these records, as if the universe were teasing us with glimpses of ever greater wonders. What we call the largest known black hole is always a temporary crown, soon to be passed to another, hidden farther away. Every discovery is both an answer and an invitation. As our instruments grow sharper, the horizon of knowledge expands, a tide that never retreats. These record breakers remind us that the cosmos is still writing itself, one measurement at a time. And beyond the known, countless unseen monarchs rest in the dark, waiting their quiet turn to be found. Fact 69. Hidden giants. Most black holes will never reveal themselves. They lie dormant, starved of matter, invisible even to the keenest eyes. Their gravity shapes galaxies, yet they whisper no light, no signal, only influence. Some drift through intergalactic space, remnants of galaxies long since consumed. Others sit at galactic centers, sleeping, their fires extinguished until the next infall of gas awakens them. Though unseen, they are everywhere. The silent majority of the cosmos, holding the scaffolding of creation together. To think of them is to feel the hum beneath reality, a stillness vast enough to cradle all that shines. Fact 70. The ceiling of gravity. Even the universe has its limits. For all their power, black holes cannot grow forever. There comes a point when the flow of gas, stars, and dust around them becomes too thin, too scattered to feed their hunger. Beyond this, the cosmic expansion pulls matter away faster than gravity can reclaim it. Physicists call this natural boundary the ceiling of gravity, the theoretical limit to how massive a black hole can become. Perhaps it is near 100 billion solar masses, perhaps greater, but somewhere the balance tips and the growth slows to stillness. It is comforting, in a way, that even the most infinite-seeming forces know quiet boundaries. And at that edge of power, human curiosity begins its own horizon. Fact 71. The edge of knowledge. There are regions of the cosmos where equations falter, places where our understanding becomes as thin as the interstellar air. Black holes mark this frontier. We can describe their effects, predict their shadows, but we cannot yet see their centers or hear their full story. Each discovery pulls us closer to that threshold, and each answer opens more gentle uncertainty. Perhaps that is the nature of exploration, not to master the unknown, but to learn how to listen to it. At the edge of knowledge, humility feels like wonder, We stand in awe, gazing into the dark, and the dark quietly gazes back. And within that gaze lies one of the universe's most poetic puzzles. What happens to all that falls inside? Fact 72. Information in the dark. When something crosses the event horizon, its matter disappears. But what of its information? The record of what it was? Does it vanish too, or linger somehow upon the surface of the void? This is the information paradox, a mystery that has stirred physics for decades. Some believe that the information is encoded in faint quantum ripples along the horizon, written into the fabric of space like delicate script. Others think it transforms, reborn in forms we cannot yet name. Whatever the truth, it tells us this: nothing in the universe is ever truly lost. It only changes form, like thought dissolving into dream. Fact 73. Hawking's Whisper. In the 1970s, a young physicist named Stephen Hawking listened closely to the mathematics of the universe and heard something unexpected. His calculations suggested that black holes were not completely black. They should, in fact, glow ever so faintly, emitting a gentle radiation born from quantum effects near the event horizon. This Hawking radiation is unimaginably weak, too faint for us to detect yet, but its meaning is profound. It tells us that even the darkest objects are not eternal, that they too can breathe, release, and fade. Hawking's whisper reshaped our understanding of the cosmos, reminding us that even silence carries a soft voice. And through that whisper, eternity began to feel beautifully fragile. Fact 74. Evaporation of eternity. Over trillions upon trillions of years, a black hole that no longer feeds will slowly lose energy through Hawking radiation. Its mass decreases grain by grain, light by light, until the enormous becomes small, and the small finally dissolves into nothingness. This slow fading is the ultimate patience, the long unwinding of gravity itself. A supermassive black hole could take more than 2100 2100 years to evaporate completely, its warmth dwindling to a final ghostly spark. When that last flicker comes, it will release a faint burst of energy, the final heartbeat of a cosmic giant. And after that, only calm remains, an infinite pause between the universes to come. Fact 75. Entropy of the infinite. The strange thing about a black hole is that its surface, its event horizon, holds its secrets. The area of that surface determines its entropy, a measure of how much information it contains. The larger the horizon, the greater the entropy, the deeper the complexity. This idea reveals a quiet irony. The simplest looking thing in the universe, a sphere of perfect darkness, may also be the most intricate. Every piece of matter, every photon it has swallowed, leaves a faint trace in that hidden order. Black holes are not emptiness. They are memory made invisible, the universe's way of keeping its most beautiful secrets safe. Fact 76. The holographic universe. From the strange marriage of gravity and quantum physics came a breathtaking idea that the universe may be holographic. Just as a hologram holds a three-dimensional image within a two-dimensional surface, all the information inside a black hole might be stored upon its horizon. In this view, reality itself could be a projection. The three-dimensional world we know unfolding from data inscribed on the thin edges of space. The event horizon becomes both boundary and book, recording every whisper that crosses it. It is a thought at once humbling and soothing, that existence is written in light upon darkness, and that every moment leaves its mark on the quiet skin of the cosmos. Fact 77. Wormholes and dreams. Some equations suggest that black holes might be connected to their opposites, white holes, where matter and energy flow outward instead of in. If such a bridge existed, it could form a wormhole, a tunnel through space-time linking distant corners of the universe. We do not know if these passages are real or merely mathematical dreams, but the idea endures because it feels like the universe remembering itself, a cosmic shortcut through both space and story. If wormholes exist, they would be fragile, flickering windows through which time and distance blur. And though we may never cross one, it is enough to imagine them, to feel that somewhere, even the darkness has a doorway home. Fact 78. The mathematics of mystery. The language that describes black holes is not of words, but of numbers, curving tensors, gentle infinities, and equations that weave geometry with time. Yet in their precision lies something almost poetic. Each formula traces the same truth, that gravity is not a force, but a shape, not a pull, but a harmony. To read these equations is to glimpse beauty stripped bare, the architecture beneath all things. They do not merely predict the dark, they compose it, line by silent line. And in that mathematical rhythm, the universe hums its most ancient song. Beyond that hum lies the flicker of the smallest possible worlds. Fact 79. Quantum foam and the abyss. At the tiniest scales, smaller than atoms or light waves, space itself begins to shimmer. Quantum theory tells us that emptiness is not truly empty. It seethes with brief sparks of energy, particles appearing and vanishing in the blink of a Planck time. This restless fabric is called quantum foam, and near a black hole it may ripple wildly, shaping the behavior of space and time at the event horizon. The boundary between something and nothing becomes soft, like the surface of a deep sea stirred by unseen currents. In that microscopic froth lies the foundation of reality, the smallest notes in gravity's grand symphony. And from those notes, the universe builds even the silence of black holes. Fact 80. The symmetry of nothing true. Emptiness, if such a thing exists, might be the most balanced state of all. In physics, symmetry often means harmony. Forces aligned, energies equal, creation and destruction in perfect correspondence. Black holes embody that symmetry. They are the simplest objects we know, described entirely by mass, spin, and charge. Yet they represent the ultimate complexity of matter transformed. In their depths, all distinctions fade, leaving pure geometry behind. To see that simplicity is to glimpse the peace at the heart of chaos. The void is not cruel or cold. It is equilibrium, a quiet breath between universes. Fact 81. Ancient shadows. Long before the word black hole was ever spoken, humans looked to the heavens and felt the same mixture of awe and fear. Ancient myths told of celestial gateways, underworld suns, and cosmic serpents swallowing light, metaphors for something vast and unseen. The Babylonians, Egyptians, and early Indian astronomers all spoke of dark stars or holes in the sky that devoured brightness. Though they did not know the science, they sensed the truth, that creation and destruction are forever intertwined. Across millennia, our stories have always sought the same comfort, that the darkness above is not an ending, but a beginning in disguise. Fact 82. The black sun of alchemy. Centuries before the telescope, mystics and alchemists wrote of the black sun, a symbol of transformation rather than light. It represented death that leads to renewal, the shadowed furnace in which old forms dissolve to make way for the new. They did not know of gravity or relativity, yet their metaphor mirrors what black holes truly are. Places where matter is broken down, its structure lost, its essence returned to the simplest state of being. In the black hole's stillness, the alchemist's dream finds its echo. That darkness can purify, that endings can cradle beginnings, and from that quiet rebirth, new light may someday arise. Fact 83. The language of darkness. Every culture has found a way to describe the unknown. In ancient China, darkness was yin, receptive, balanced, essential. In Sumerian myth, it was the fertile void from which the first gods were born. In Western science, it became the backdrop for discovery. To speak of black holes is to continue that old language of darkness, a conversation stretching back to the first stargazers. We describe the unseeable not with fear, but with reverence. The void is not absence, but potential. Not loss, but promise. Our words change, but the tone remains the same. Soft awe before the endless night. Fact 84. Einstein's reluctant monster. When Albert Einstein first formulated his equations of general relativity in 1915, he never imagined they could predict something so extreme. Yet hidden within his math was the possibility of a point where space and time collapsed entirely. Others saw it. Carl Schwarzschild calculated the first solution while serving in the trenches of World War I. His result described what we now call a black hole. Einstein himself doubted such a thing could exist. It seemed too strange, too final, and yet the universe proved him wrong. The reluctant monster of mathematics was real. It had been waiting all along, patient beneath the veil of stars. Fact 85. The first theorists. After Einstein's discovery, a few daring thinkers gazed into the dark math and decided to trust it. In the 1930s, J. Robert Oppenheimer and his student Hartland Snyder proposed that a collapsing star might never stop falling. It would curve space so completely that even light could not escape. Their prediction was quietly radical, a scientific whisper, against the noise of disbelief. At the time, few listened. The world was not yet ready to accept that nature could hide herself so completely. But they were right. Their equations described the universe's most secret places, long before anyone had seen their shadows. And one day, a single star would prove them correct. Fact 86. A star named Cygnus X Nin. In 1964, a small satellite detected mysterious X-rays streaming from a patch of sky in the constellation Cygnus, the Swan. The light flickered as though coming from a tight orbit, a massive, unseen object devouring its companion star. Astronomers named it Cygnus X1. For years they debated, was it merely a dense cluster of matter or something deeper? Eventually, the evidence aligned. The mass, the motion, the spectral lines, and the verdict was clear. Cygnus X1 was the first strong candidate for a black hole. The theory had stepped out of mathematics and into the night sky, where it still shines. A soft pulse marking the moment mystery became real. Fact 87. Seeing the unseen. As technology grew, so did our ability to witness the invisible. Radio telescopes mapped jets of plasma, X-ray observatories traced hot gas, and gravitational detectors listened for the faint tremors of cosmic mergers. Each new tool revealed another piece of the black hole's quiet anatomy. Its feeding rhythms, its spinning heart, its light bent into halos. None of these machines see with eyes. They listen, infer, and translate vibration into vision. Through them, we've learned that even darkness has a pattern. Even silence has texture. To see the unseen is not to banish mystery, but to invite it closer, softly, respectfully, into knowing. Fact 88. The spin of space. Black holes do not simply pull, they spin. When a massive star collapses, its rotation cannot disappear. It's conserved, concentrated, intensified. The result is a black hole whose very fabric of space-time whirls around it like a vortex. This spinning distortion, called frame dragging, means that near a rotating black hole, space itself is carried along. A particle dropped nearby will be swept into motion, even if it tries to stand still. Time and direction twist together, graceful and inevitable. The faster the spin, the narrower the horizon, the deeper the beauty. A black hole is not a void, but a turning, a slow cosmic dance where even space remembers to move. Fact 89. Jets of light. Some black holes are quiet eaters, while others transform their hunger into spectacle. When magnetic fields near the accretion disk wind and snap, they funnel matter into twin jets that burst outward at near light speed. These relativistic jets can stretch thousands of light years into intergalactic space. Within those beams, charged particles spiral, glowing in radio and X-ray light. To distant observers, they appear as shining lances, threads of light woven through darkness. The paradox is perfect. From the deepest, gravity well, the universe launches its brightest flares. Destruction becomes creation, and the quiet heart of the abyss paints the heavens with fire. Fact 90. Magnetic sculptors. Magnetic fields are the silent artists that shape a black hole's surroundings. They rise from the swirling plasma of the accretion disk, invisible yet powerful, twisting matter into elegant spirals and jets. Without magnetism, a black hole would merely consume. With it, it creates, forming order from turbulence, structure from chaos. In simulations, magnetic lines ripple like silk, guiding the rhythm of falling light. Through their unseen guidance, black holes become sculptors of galaxies, quiet conductors orchestrating energy and form. Every flicker of a jet, every pulse of radiation is magnetism whispering through the cosmos. Fact 91. The choir of galaxies. Across the universe, galaxies form clusters, hundreds, even thousands bound together by gravity's long reach. Each has a supermassive black hole at its heart, and though separated by millions of light years, their rhythms align. Astronomers studying gravitational waves imagine these black holes as voices in a deep, low choir. As they orbit, merge, and sing through space-time, their combined hum fills the cosmos with a constant faint vibration. It is not sound as we know it, but the harmony of motion, galaxies breathing in unison, their central hearts keeping time. Through their silent music, the universe reveals its pattern: gravity as melody, light as refrain. Fact 92. Black hole feedback. Despite their fearsome reputation, black holes do not simply devour, they also give back. When they feed, they release enormous energy into their surroundings, heating gas, stirring dust, and regulating how stars form. Astronomers call this process feedback, and it is the heartbeat of galactic life. Too little energy, and galaxies collapse under their own weight, forming stars too quickly. Too much, and the gas is swept away, halting creation entirely. But in balance, a black hole's gentle breath sustains the delicate rhythm of growth. They are gardeners, not destroyers, shaping galaxies with invisible care. Through destruction, they cultivate harmony. Through silence, they teach restraint. Fact 93. Galactic gardens. When viewed from afar, a galaxy appears as a swirl of light, but beneath its beauty lies careful design. Black holes at their centers control the flow of gas that feeds both stars and planets, pruning excess, seeding structure. In this quiet way, they tend the cosmic gardens, the places where suns ignite and where, in time, life may bloom. Without their regulation, galaxies might burn too fast or fade too soon. So even as they rest in darkness, black holes nurture everything that shines. They are the still roots beneath the blooming stars, the unseen hands that keep the garden of night alive. Fact 94. Distant watchers. When we gaze at the night sky, we see it, alive with stars, yet this brightness is temporary, a fleeting bloom in cosmic history. Far in the future, when most stars have faded, only black holes and the faintest embers will remain. These ancient watchers will drift through the quiet dark, marking the remnants of galaxies long dissolved. Their gravity will still whisper, shaping the faint orbits of dead stars and cold dust. To any mind that might exist then, they will be the constellations of eternity, silent markers of what once was. Even in that future darkness, beauty endures. The watchers will not shine, but they will keep the memory of light. Fact 95. The fate of galaxies. Over billions of years, galaxies like our Milky Way will merge and fade, their stars consumed or ejected, their gas exhausted. In time, supermassive black holes at their cores will spiral toward one another, merging into still greater giants. The result will be quiet, no explosion, no blaze, only a soft gravitational ripple spreading through infinite space. These merged galaxies will glow dimly for ages before their last stars die, leaving behind black holes and the faint whisper of once living suns. The universe will not end in violence, but in rest, a long exhale after a life of endless motion. And even that stillness will be perfect in its calm. Fact 96. Cosmic stillness. In the farthest future, 100 trillion years or more, all stars will have gone dark. The universe will become a sea of black holes, drifting apart as space continues to expand. Slowly, they too will fade, evaporating through Hawking radiation until only quiet energy remains. This is the age of cosmic stillness, where time stretches endlessly and change becomes rare. Yet even here, there is peace, the final rest of all that was. The same gravity that once ignited suns will settle into eternal equilibrium. The night will deepen, but it will not be lonely, for the memory of every star will still hum softly in the dark. Fact 97. The last light. In a distant age beyond imagination, the universe will glow faintly with the light of dying stars, red dwarfs burning their final reserves of fuel. They will be small, cool, and dim, shining softly for trillions of years before fading into black embers called black dwarfs. When the very last of these flickers out, true night will fall. Yet, it will not be an ending, but a moment of exquisite calm, the last shimmer of warmth before the eternal hush. Somewhere, perhaps, a lone black hole will still reflect that final ray, bending it once more into a spiral of beauty. The universe will sigh, and in that sigh, remember itself. Fact 98. When black holes die, even black holes, those seemingly immortal anchors of gravity, are not forever. Through the slow leak of Hawking radiation, they will shrink, imperceptibly at first, then faster as they lose mass. A black hole that once devoured suns will eventually glow faintly with its own fading heat. When the end comes, it will be silent. A brief flash of energy, a whisper of light, then nothing. The last black holes will die long after galaxies and atoms are gone, leaving behind a universe emptied of form, but rich in memory. Their passing will mark the final breath of structure, a gentle return to equilibrium. The cosmos asleep once more. Fact 99. The whisper of the end. After the last black holes fade, there will be no stars, no light, no motion, only the quiet hum of residual energy spread thin across infinite space. Physicists call this the heat death, but it is not a violent ending. It is serenity. The universe settling into its final, perfect balance. Every atom that ever existed will have played its part. Every photon will have journeyed as far as it could. Nothing is wasted. Everything has become still. And in that stillness, perhaps, there will be a memory, a whisper echoing through time. Once, there was light. Fact 100. The dream of return. Even in the farthest silence, some theories whisper of renewal. Perhaps the universe, once stretched to stillness, will one day fold inward again, its quiet fabric curling back upon itself. Gravity, patient as always, could draw everything home, reversing the long expansion. If that happens, light will return. Faint at first, then bright, as the cosmos warms and blooms once more. The ashes of ancient black holes may become the seeds of new suns, new galaxies, new beginnings. No one knows if this cycle is true, but it feels right, somehow, that the story of creation never truly ends. That even in the deepest dark, the dream of return softly lingers. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, traveler, and I'll see you among the stars.